This section describes the initial setting of parameters. Launch ProDrive next on the PC. Create a new project? Select Y to create a new project. Next, connect the driver to the PC. Click the Online button. Once connected, the status of the device can be checked. The connection can be disconnected or reconnected here. The next step is to change the parameter settings. The table shows the items that must be changed in the settings of NT55V and NT80V. The model number to be set here is NT80V65/5, which is the part in the red frame. Start setting then. When the parameter setup window opens, click on the tab FA. After clicking, move the cursor down to locate FA82 and FA85. FA82 sets the encoder resolution to 15,000. FA85 sets the linear scale accuracy to 0.5. Next, click on the tab FB. Look for FB20 and FB21 in the parameters. FB20 sets the forward speed limit value to 1330. FB21 sets the reverse speed limit value to -1330. After writing, to send the changed FA and FB values from the PC to the driver, click Parameters on the menu bar. Click Download Changed Parameter. After download is completed, confirm that each value has been changed. After checking, an error appears on the left side of Servo Linear ADV in the project tool. The alarm occurs because the resolution value has been changed. Therefore, reboot the driver. After reboot the driver, connect it to the PC again. After connecting, check the parameter values are the changed values. The initial setting of parameters is completed. The next is the mass estimation on the nonlinear. Switch the tab to Device Status and open Auto Tuning. Open Offline Auto Tuning in the Auto Tuning section. Click Servo on plus EST Mag in the upper left corner of the window. Click Start to servo on the product. After servo on, click on Load Mass Estimation. When the Load Mass Estimation screen appears, click Start Estimation. The estimated load mass ratio FB01 is displayed in the yellow column of the screen. This is the process of load mass estimation. The following are points to note when estimating load mass. Next, let's try homing. Open Start Homing in the Auto Tuning section. Click Start. It hits the mechanical stopper, reverses, and searches for the origin signal. Click Servo Off to close offline auto tuning. Click on the Device Status tab. click Jogging on the device status window. After opening the jogging window, select Jogging Method. Select the pulse feed jogging to direct distance. Change the pulse feed from please to millimeter in unit. Enter 5 for the pulse feed. Enter 100 for the jogging speed. Enter 0.02 for the acceleration time. Enter 0.02 for the deceleration time. Click Servo onto excitation. Click the continuous action button to execute the back and forth motion. Next, optimize the filter settings. Go to the Parameter setting window. Click on the FD tab. Enter 0.15 in FD06, 0.4 in FD15, and 0.2 in FD17. These values for the filter are examples for status not to impair high response. If you have any of the following requests, please follow the procedure to set them up. After input, click on Parameter in the menu bar to send the changed FD value to the driver. Click Download Changed Parameter. Then, let's trace the current operation status. First, open the Device Status tab. Click Trace on the Device Status window. After switching to the Trace window, set the trace subjects. First, set the analog trace target 1 to the position command pulse input frequency D96. Next, set the analog trace target 4 to the position error monitor LD09. Next, change bit number 3 of the digital to INP2. Next, remove all check marks except 3 from the digital section. Next, set the trigger on the analog 2 speed detection value monitored 01. Next, set the sampling period. Enter 10. Next, set the pre-trigger count and trigger. Enter 50 for the pre-trigger count and 10 for trigger. After setting, click on Single Trace Execution. Remove the check mark from Autoscale. Next, change the display range setting. Here, save the trace data file for later comparison. Now, let's do auto-tuning. First, auto-tuning is not available while the jogging, so click Stop, then Servo Off. Next, click the Auto-Tuning tab and select Offline Auto-Tuning. When the window opens, click on Servo On. When Servo On, click Auto Servo Gain Tuning. Click on Change Conditions to set the tuning conditions. Enter the following values to set the motion profile settings. Click Set. Change the machine stiffness level to 3 and click Set. Here the change conditions has been completed. Click Start Tuning. When auto-tuning is executed, position and speed cutoff frequency is performed first. Specifically, the parameters for speed control proportional gain FD01 and position control cutoff frequency FD09 in the red frame are tuned. After tuning of position and speed cutoff frequency, fast positioning tuning mode is performed. Specifically, the parameters for position feed gain FD10 and position feed forward filter time constant FD41 in the red frame are tuned. When auto-tuning is completed, parameters are set automatically. Next, click on History. The servo gain tuning history is based on the number of operations. The positioning setting time and overshoot pulse are displayed in the tuning records according to the number of operations. Focus on the range in the graph where the data is stable. Shift plus left click to zoom in. Select the each smallest point among the blue and red cursors. Left click for blue cursor, right click for red cursor. Write the selected blue or red cursor parameters. Write either parameter of blue or red cursor depending on customer's desire. In this case, the blue cursor, which has the smallest position settling time and overshoot pulse. Auto-tuning is now complete. Now, let's check the status after tuning. First, start jogging with click on Servo On. Go to the Trace window on the tab. Open the saved trace data file before auto-tuning. Set the trace type to single and click on Trace Run. As can be seen in the graphs, the positioning, settling and position error have been improved. Before tuning, the speed detection value is delayed relative to the speed command value. As you can see in the speed detection value monitor, it takes time to stop at the target position, and the actual positioning time is 150 milliseconds. After tuning, there is no delay in the speed detection value relative to the speed command value, and the actual positioning time to stop at the target position is reduced to 50 milliseconds. The settling time is almost 0 milliseconds.